So let's go back to the back propagation, right? So today we have to do the back prop, and as I told you, right, this is the figure that you have, okay? And there is something called a delta rule, which we will see based upon this is a delta that is sitting there, okay? So let's start with. So the idea is that, right, the back is a propagation. The reason why it is called back propagation is because you actually propagate the error back from the output layer back to the input layer, okay, so as to be able to improve upon the weights, right. The idea is that you want to calculate the unknowns, right, the weights and the biases, and the way you do it is by actually back propagating the error, okay, and you want to make the error as small as possible. So use a gradient descent, you sort of update, right, you update such that the overall loss will actually decrease. That is that we had a gradient descent equation, right, except that this is main. So this is a way to solve the optimization problem, okay. Now so I would just like you to write, keep this figure in mind. So L equal to 1, L equal to 2, L equal to 3 and L equal to 4. This is just a very simplistic sort of a picture. In a real situation it will be far more complex, okay. And then out here, right, the weights are like Wij for the Lth layer, Wij L, Bil, and that takes you from the Lth to the L plus 1th layer, and so right, that is why the weights are named as such. And I typically refers to the ith node, okay. Of course, in between there could be little changes, but generally, right, I will refer to the ith neuron, and then y1 hat and y2 hat are the actual output, right, out of this network, and let us say that right, you have a cost, and eventually, right, what is the goal? Okay, so the goal is, let us say that we have L theta, where this theta is weights and the biases, and these weights by which we mean all over, okay, not just in one layer to next or something, the entire set of weights, the entire set of biases. So let's say, right, we have a regression problem. Let's just make it simple, okay. It doesn't matter, you can change the cost if you want, but let's say that we have got two nodes, right. So let's just scale it by half, and let's say that we have something like I equal to 1 to 2 yi hat minus yi square. Okay, let's say that right, that is our cost which we want to be kind of minimized. Yi is like sort of a ground truth value. Okay, this is a ground truth value which we know, and we want a network to actually produce a yi hat such that for every I, yi hat is as close as possible to yi, right. That's the goal. And as we know, right, we want a derivative with respect to whatever, right, a w and with respect to b and so on. But then before we calculate that, let's first write down these equations, okay. So let me first write down the z. Okay, now if you notice here, right, z is prior to the activation, a is after the activation, right. So we'll first write down z, which is prior to the activation, which is simply a linear combination, and ai will be after you apply the activation, right. So now I'll start from Zi4, okay, or for that matter, yeah, we can start from anywhere. Okay, so let's start with Zi2. Okay, we'll start from this end. Okay, just to be in tandem with this. So Zi2, okay, Zi2, if you notice, right, that will be summation, okay, this is I, okay, Zi2 will be summation. Now if you see, right, it's no, so Zi gets inputs from x1, so it gets inputs from x1 and x2, and therefore, right, this will be like summation Wij 1, right, because that's the weight for the layer going from 1 to 2, and j going from 1 to 2, xj, because that's the input, plus you have bi of 2, and I going from, see, I mean, you have to see as to how many neurons are sitting there, right. So I going from 1 to 4. So I going from 1, 2, 3 and 4, and then you can write down ai2, and yeah, and then this is applicable to any neuron, right, in that layer, and ai2 will be simply some activation function applied on Zi2, right, and again I going from 1 to up to 4, and similarly, right, we can write down Zi3 perhaps, right. So the layer coming up next. So if you see, right, if you see what is coming into Zi3, what is coming in are the weights Wij2, and it's not square, right, that you understand, it's Wij L. So it's not like squared or something, right? Wij2. So superscript is just a superscript, it's not a square or something. And it's getting inputs from where? It's getting inputs from AI, right? That is what is coming in as input to the layer L equal to 3. And therefore, when you try to write down Zi3, right, what will you have? So, you will have summation Wij and then 2, right, because that is a bunch of weights, and then what will you write here? Aj, what is this? Aj2, right? So, Aj2, J going from, but J will go from where to where now, because it is receiving from 4 neurons, right? You guys are following, right? See, I am trying to write down this Zi, okay, as a function of these weights. The bias is of course associated with this, which will be like, Bi2, right? So, here what will you have? You will have like Bi2, where I goes from 1 to 3, and J goes from 1 to 4, because that is where the inputs are coming to Zi, right? Okay, I mean, right, if I actually write something wrongly, alert me, okay? Wij2, so J going from 1 to 4, plus, what will you write here? Bi, oh, but see, here it should have been Bi1, okay, not Bi2, okay, that is why I am saying, right? So, you guys should be careful, okay? The first one is Bi1, by the way, here, okay, and this will be Bi2 plus Bi2, and now I goes from, what will I go from? 1 to 3, because you have only, say, right, 3 neurons there. So, I goes from, sorry, is that correct? 1 to 3, right? So, I goes from 1, 2, and then 3. And then you will have Ai3, which is simply f of Zi3. And then finally, right, we can write down Zi4, because Zi4 is this last guy, right? And Zi4 receives inputs from, so the inputs to it are A13, A23 and all. And then you will have W113, and then what will you write here? You will write this as, well, I mean, so Bi3, no, B1 for the first neuron and B2 for the second neuron. So, I will just write it as Bi3, and therefore, what will you have here? So, Zi4 will be like summation Wij 3, right, and then Aj3 plus Bi3, except that J will now go from 1 to 3, right, and I goes from 1 to 2, because you only see 2 neurons at the output, right, and Ai4, which is the final output, that is f of Zi4. See, like I said, right, this f could be there, need not be there, but we will assume that it is there, okay, and this will be equal to your yi hat, by the way, and I equal to 1, 2. Right, let me just check whether we made any mistakes, or this looks okay, I think, because if we make a mistake, then it will go wrong elsewhere. I think it looks okay. So, now the point is this, right. So, now we have these output relations at every layer, and the idea is this, right. Finally, what do you want to do? You want to be able to see, the idea is this, right. You start with a set of weights and biases, which could be randomly initialized. We will see what is the best procedure to initialize and so on, but for the time being, assume it is randomly initialized. Then what will happen is, for this input, right, x1 and x2, you will get some output, right. I mean, if you simply do a forward sort of a propagation, if you forward propagate, you have the weights, you have the input, therefore, you will get outputs at every point, right, every neuron, and that will fire the next neuron and so on. And eventually, you will get some y1 hat and y2 hat, but that need not be equal to y. That need not be equal to y1 and y2, which is a target sort of, target value. So, what do? You find the error, and then you do a back propagation of the error. So, you try to go back and see, right, how this error, how the weight should be adjusted, so that the error will come down. Weights and bias always. When I say weights, I mean the bias also. Okay, that is the idea of this one, back propagation, and that is why it's clean, because if once you write this down for a small this one, right, you at least know how it works, and then one doesn't even write it in a real. When you do a real implementation, there are packages that do this automatically. You just define the cost, and then you define the network, then they do it automatically. But I thought once at least you should do it, so that, right, you understand what the intricacies are, right. Then let's now the point is, right, now let's kind of go and look at what to say, dou L by, let me say, let's start with the first one, which is dou L by dou Wij3, okay, dou Wij3, okay. So, if you see here, right, go back and see this diagram. So, you have like dou L by say dou Wij3, which is here, right? Wij3 is here. Therefore, I mean, and it's all an application of chain rule. Okay, the whole process is simply an application of chain rule. Okay. So this you can, so right, so this I am going to write it, I mean, right, you will, I mean, you can verify this for yourself. So this will be, right, so Zi4, right. So this will be like dou L by dou Zi, and now, and we write it in a particular form because this involves what is called a delta rule, and that that involves doing it in a certain way, okay. Not that this is the only way to do it, but Zi4 by dou Zi4 by dou Wij3. Okay, and of course, right, we'll have to find all these values, you know, independently. But now, but let's just kind of look at this equation that we had. Okay, see the Zi3. Okay, right, Zi3 is in this form, right? This is what you have. Okay, and let's go to this next one. So you have Zi4. So see Zi4. Sorry, you have to look at Zi4. So Zi4 is here, and if you do dou Zi4 by dou, right, Wij3, what will you get in this equation? Aj3 is what you will get, right, and therefore that is what will be the second term there. So right, this is going to be Aj3, and let's call this as delta I4. Okay, this is just a notation. Okay, this quantity, you know, we will explore this a little, you know, in more detail. For the time being, just call this delta I4. Okay, and then this is Aj3. Then let's look at what is delta J by dou Wij2. Okay, this again, right, we will write it as again, okay, dou L, sorry, no, not dou J, dou L, and this will be like dou L by, I mean, again, right, I mean, you just have to follow whatever we did just now. So now we are looking at dou L by dou Wij2, and that you can write as dou L by dou Zi3, and then into dou Zi3 by dou Wij2, right. Therefore, you can write this as dou Zi3, and then dou Zi3 by dou Wij2, and this now just by a notation, right, this will become delta I3 now, and Zi3, right, if you just watch this equation, Zi3 is here, and if you take with respect to Wij2, you will get Aj2. Therefore, right, this becomes Aj2. Okay, this becomes Aj2, and then we will have finally dou L by dou Wij1, and that will be dou L by dou Zi2, right. I don't even have to see the diagram, right, this is what it should be like, and dou Zi2 by dou Wij1, and I just expect this to be Aj1, right, which you can verify, Aj1, and this is going to be delta I2, right. Oh, sorry, okay, no, yeah, this is one change, right, because of the input, right, what you have is xj coming in, right, therefore it is not aj, so aj becomes, I mean, there is no aj there, right, I mean, if you just notice, I mean, when you talk about Zi2, the input is xj, right, the rest of the places you had aj and all, at the first layer you have xj, right, and therefore this becomes, so I'll just put this as xj, the last one alone, right. So this, let's not call it aj, let's call this xj, there is no 1 and all there, earlier ones had xj1, aj2, this is just xj. Okay, now, right, this is on the one hand, right, which we have. Now let us actually examine this one, right, okay, delta I4, okay, let's examine delta I4. Okay, and delta, because see, the idea is that you want to do a back propagation, so you have to start from the output layer and come all the way to the input layer. So if you can find out delta I4, then the idea is that we want to be able to find out delta I3 in a sort of a, you know, a recursive manner using delta I4, then delta I2 using delta I3, and we want to kind of go like that. We can show that it can be done. Okay, that's called a delta rule, delta learning rule, that's what it's called. So let's look at delta I4, right. So delta I4 is dou L by dou Zi4, and L, right, we wrote down, right, L is simply half whatever, right. I mean, that half is because we have two outputs there, I equal to 1 to 2, and then we had yi hat minus yi square, right, and therefore, and this yi hat, okay, now this is, so if you look at this, right, so if you do dou L by dou Zi4, right, that will become 2 will cancel off, right, you will have like yi hat minus yi, and then you will have dou yi hat by dou Zi4. But yi hat, right, if you observe, yi hat is what? F of Zi4, right, and therefore this is simply f dash of Zi4, right, this is simply f dash of Zi4, right, and we know that y hat we know the value actually, we can actually compute it because yi hat is coming through the input and then the weights, right, that we have initialized with. Therefore, actually, so in that sense, right, so delta I4 you know now, So, right, this is a forward pass in a sense, right? You do a forward propagation with a certain set of weights that you randomly initialize. You will get a yi, you will get the out, I mean, you can compute delta I4 because yi hat is known to you, yi is the ground truth, which you know what you want it to be. Then yi, right, f dash of zi4, right? Everything you know. But now the more interesting part is how does delta I4 connect to delta I3, how does that connect to delta I2 and so on. I mean, that's where the power of this whole thing lies in a sense. Where? No, no, you're doing with respect to zi, right? Is there a summation? No, because you have y as a subscript I, no? Therefore, it will only work for that I, right? You're doing zi4, right? It's with respect to a particular value of I, right? So, the summation won't be there. So, delta I3, let's kind of look at delta I3. So, delta I3 is here, right? So, delta I3 is dou L by dou zi3. Okay, let's just go back to that figure, right? So, what you have is, so your L is out here, right? That's your cost. Whenever I write L, that's at the output, right? So, you're talking about dou L by you see dou you see what do you call dou no zi3, right? So, yeah, so one way to write it again, right? This is not a most unique way, but what I can do is I can write this as dou L by dou ai3 into dou ai3 by dou zi3, right? I mean, I can come like this, right? You can come like dou L by dou ai3 into dou what is this dou L by dou ai3 into dou ai3 by dou zi3, right? So, I'll write it in that form. I'll write this as dou L by dou 3 into dou ai3 by dou zi3. Now, if you see, right, ai3, I mean, so if you change zi, right, what gets affected? If you change zi3, right, what gets affected is ai3. Okay, and in fact, ai3 is f of zi3. Therefore, this is simply f dash of zi3, right? This is simply f dash of zi3. But then something will happen here. This is a little more tricky because if you change ai, right, if you change ai, okay, it's not just it's not that it will affect only zi4. It will also affect z14, z24. If you had further neurons in the output, right, it'll affect all of them. See, right, I mean, you see the connection, right? I mean, if you change zi, it affects only ai, and therefore there it's only one term. Okay, till now, right, we did not encounter a situation where if I change one thing, right, then there are see multiple things, right, you know, right, which get affected. This is a chain rule which I'm sure you're all aware of, right? Maybe you must have done it to your 11th and 12th and all, right? So, what this means is that this dou L by dou ai3, now that will have to be expanded now, right? It'll have to be written in terms of a summation now, because changing ai3 does not affect, you see, no, because right, this input is going here also, right? I mean, I'm just drawn with one line, but right, if I had multiple guys down here, it'll go to every one of them, right? And therefore, every one of them will get affected. Therefore, you have to take that into account, right? Therefore, what we'll have to do is, so right, this term alone, so if you just examine dou L by dou ai3, this term alone, right, we have to be careful. So, this we will have to say that, right, this will so where is our ai3? So, ai3 is here, right? So ai3 is going to affect all of them, and here we have taken a simple example. So, we can write this as just to keep our notation simple, we will say j equal to 1 to 2 because there are only 2 neurons that get affected by this guy, right, in our case. Okay. Again, it depends, I am writing it for the specific case, for the specific simple example. So, right, j equal to 1 to 2, then where is this? Okay. Then we have dou L by dou zi4. Where is this? Now, we want yeah. So, you want what? You want what do you want? You want dou L by dou ai3, right? What is this? What is that we want? You want dou L by dou ai3, right? And therefore, we can write it as dou L by dou zi4 and dou zi4 by dou ai3, okay, as a summation. So, zj4, yes, because the summation is over j. Yes, you are right. Not I, because I am summing over j. So, dou L by dou zj4 and dou zj4 by dou ai3. This is okay. Now, if you look at dou L by dou zj4, what is that? Delta j4. right? This guy is delta J4, not I, J. Okay. Now Zj dou Zj4 by dou Ai3, right? So let's again go back to our equation. So let's see Zj4 relation with I don't know why this goes off. See Zj4, where is our Zj4 is here, right? And but here where we wrote Zi here and then Aj was coming on the other side. Now we have it the other way, right? So what will that be equal to? Now if you do dou Zj4, right, by dou, what is it, Ai, that means you have to just replace the summation, I mean J here, I there, it will become Wji3, right? It will become Wji3, we can't write Wij because it's reversed, right? So therefore this will become W, so this will become Wji, what is it, 3, right? Wji3. Okay. Then what this means is that I can then go back, right? See, the whole idea is to be able to write this. So, I will write this as delta I4 is equal to yi hat minus, where is this? So, f dash, okay, no, we are writing delta I3 in terms of delta I4. So, let us write delta I3, right, is equal to dou L by dou A. So, this is like summation j equal to 1 to 2 delta J4 W J I3, this whole thing in a bracket, right, because this is summed over J, and then, okay, right. So, basically this term is this, and then into f dash of Zi3. This is delta I3. Now, let us actually look at, okay, now maybe I will do it here itself, right. Let me do delta I2, because we want to be able to know once and for all, right, what will happen. So, I think, right, delta I2 will then be right from here, right, you can see delta I2 is dou L by dou Zi2. Again following the same thing, right, I will write this as dou L by dou Ai2, I will just follow the same thing, right, and then dou Ai2 by dou Zi2. This again will become f dash of Zi2, right, I mean that is straightforward. Now, dou L by dou Ai2, right. So, if you see Ai2, so here, right, so Ai2 is here, so Ai2 affects how many neurons? I mean 3 of them, right. So, it will affect like Z13, Z23 and Z33, right, if you change any of the AJ2s or AI2s, and therefore, right, therefore what will happen? So, you have dou L by dou Ai2, so this I will write this as summation, again I will write this as dou L by, what do you have here for Ai2, dou L by dou Zi3, right, dou L by dou Zi3 and dou Zi3 by dou Ai2 or AJ2, okay, in this case. So, you get dou L by dou Zi, no Zj, okay, because we have I on the left, no, so I can't put I here. So, this is delta I2. So, we will again change this notation to J, we will go like J equal to, but J will go from 1 to 3 now, because 3 of them will get affected. So, we will get like J equal to 1 to 3, and then you have got like dou L by dou Zj3 and then dou Zj3 by dou, what is this, Ai2, right. Alert me, okay, if anything is, if we are making, you know, a mistake somewhere. Now, this is delta 3, right, this is our delta J3 and Zj3 by, okay, so this again, right, you can go back and check that. So, Zj3 is here and then you are taking with respect to Aj2, therefore, it will become Wji2. So, this becomes summation delta J3 Wji 2 f dash of into, okay, f dash of Zi2, right. So, which then means that right, we can write a recursive sort of a relation, recursion, I mean along the path, right, which looks like this, right. So, what can we say? So, we can say delta I L, right, is equal to, we can write this as summation, let us say j equal to 1 to, I am going to write this as, let me use some sort of a notation, SL plus 1. Okay, what does that mean? SL plus 1, what should it mean? Number of neurons in the L plus 1th layer. Okay. So, SL plus 1 is the number of neurons in the L plus 1th layer. Number of neurons in L plus 1 layer, L plus 1th layer. And then we have, what do you have here? Then dou j L plus 1, right? See here, no? Dou I 2 is summation dou j 3. So, this becomes dou j L plus 1, then W j I L, right? L, whole thing multiplied by F dash, then Z I L. Right, and one, of course, one can also write this in a sort of a matrix vector form to make it look more elegant, but for the time being, right, it suffices that that we have, so we know that if I start from the output, right, I can get my CD, right, delta I all the way back, or delta I all the way, okay, and I and all, right, will change accordingly, okay, in whatever layer. Sorry.
Will I go from 1 to SL?
I will go from 1 to SL then. Yeah, I will go from 1 to SL. Yeah, if you want to follow the same notation, you say I will go from 1 to SL. Right. Then, okay, let's. So what this means is this, right? So it means that all of these weights, right? I mean the gradient, which is what we are ultimately interested in, right? We are trying to. So why are we doing all this? It is because we want to apply a gradient descent. Right, and to apply a gradient descent, you need the gradient of the output with respect to the unknowns, and the unknowns, right, are for us the weights and the bias. The other thing that we have not done is the bias now, right? So we have only done the weight. So let's just do the bias part now.